Hello, this is Kapil Sharma, and this is ICP-08 submission for Big Data Analytics. And as part of this ICP-08, we learned and implemented variational autoencoders for image regeneration using MNIST dataset. And As part of this ICP-08, we have to make four changes: two in each encoder path layers and two in decoder path layers. Okay, so first imported libraries TensorFlow and Keras, and then loaded MNIST data. So MNIST data is having 10 classes, and this consists of 0 to 9 numbers which are handwritten in the form of images of sizes 28 by 28 pixel. And This is grayscale data. So then loaded in training and test set and printing the shape of that. So 60,000 images in training and 10,000 images in test. So now we will reduce the data size here because of the GPU limitations. Now printed 10 images from the training set. So this is 10. Now checking the reduced data size, so we can see like 10,000 in training and 1,000 in test set. Okay, now defining the model configuration. So width and height as 28, batch size is taking 128, number of epochs set as 50, validation split is 20% between train and testing, verbosity equals to 1 means true, and latent dimension is 2. So we will be outputting a data in two-dimensional output. And number of channels is 1 because it's a grayscale. Okay, so now reshaping the data for optimizing it. So parsing as floats and then normalizing by divided by 255, so that the train and test will be between 0 to 1. So that will be optimized for deep learning. Now we need to create the encoder, so it will be a three-step process. First step will be defining encoder, and then second step is to reparameterization, and third step is to instantiate the variational autoencoder. Okay, so here this is the first step, encoder definition, and here input layer is input, and then there are output layers as mu and sigma. And I have made changes for two additional layers with size 32 and 64 here, and I am not passing any strides, unlike these layers. So the new layers are not having any strides because we don't want to make any changes in the output. So we don't want to make any changes in the shape which is not desired, so not adding any strides. Okay, and these two layers are supposed to decrease the losses. Okay, so first is the input layer, then the convolution layer, and having sizes 16, first 8 and then 16, having filters by deploying 3 by 3 kernel, size is 3, and then again two new convolutional layers followed by a flatten layer, and then dense layer, and then the patch normalization, and again dense layer having latent mu and latent sigma functions. Okay, after that we are just taking the shape of the convolution shape, so defining it here, and then yeah, here we are doing reparameterization. So it is supposed to optimize any losses due to the gradient descent. So it will help in reducing losses due to the gradient descent. And after that we are instantiating the encoder. So instantiating the encoder, it will be having input layer as encoder input, and then there are convolution layers and normalization layers, followed by a flatten layer, dense layer, again batch normalization, and there are three output layers, mu, sigma, and lambda. Those are the three output layer. Now creating the decoder, so it will be a two-step process. First defining, and second is the instantiating it. So decoder will be having the layers in just opposite way what we were having in the encoder. So the sequencing of the layers will be just opposite, and I have added again two additional layers for the convolution that will be just matching with the uh, opposite sequencing of the convolution layers we added in encoding, and these are again added to decrease the loss of the model. So here the input layer is this input layer with latent dimension, which we have taken as 2, and here the layer name is decoder input output, and similarly the output layer, the last layer will be convolution 2D, which was the first layer in the encoding. Okay, now we are instantiating decoder, so it will be having input layer as decoder input, and output layer will be just a single decoder output. And this is also, like you can see, the same opposite sequencing of the layer. Now we will create VAE, or instantiate the VAE, variational autoencoder, and then we will compile and train it using the loss optimizer as Adam, the optimizer as Adam, and loss function as binary cross entropy. Okay, so having 50 epochs here, and then we will visualize the results here by plotting it using matplotlib library. So here we are plotting it, and you can see the result is in 2 dimension, which we were talking about, and you can see the noise has been reduced, the what we were earlier seeing, just by changing the encoding layers and decoding layers. The noise has been reduced. Okay, so still we can see some noise, but the results are better than what they were earlier. So these are the regenerated images, and you can see most of the images are taking the number size from 0 to 9. So we implemented that. Thank you.